Okay, so like I said at the end of the last video, I want you to try 5 and 7 on your own, and then I'm going to show you the answers in this video. I don't expect it to take a lot to go over, so if you haven't tried 5 or 7, try them on your own first here. For number 5, it says under one of your desks. Well, obviously, since I'm not in your classroom, I want you to use this picture. Under one of these desks, there's a prize sticker. So what's the probability that the person who wins will be wearing green or black? And then number 7, if Wyatt made 90% of his free throws he's attempted at basketball practice, what is the probability that he will make the next 3 free throws he attempts? So try 5 and 7, pause, press play when you're ready to go over it. You can do that now. Okay, so you've completed 5 and 7 at this point. Number 5, you're doing the probability here, and the probability of wearing green, well, there is 1, 2, 3, 4 students out of the 12 in the class wearing green. And then how many are wearing black? Here's 1 and here's 2. So there's 2 students wearing black. When it's an or, you add the probabilities together. So you have 6 out of the 12 chance, or 1/2, or 50%. Number 7, then, if Wyatt made 90% of his free throws he's attempted at basketball practice, what is the probability that he will make the next 3? Well, it would be make and make and make again. So 90% times another 90% times another 90%. This is going to give you 729 1,000ths, or 72.9% chance. So and means to multiply, or means to add. All right, the rest of this video is completely optional. If you want to try it, 6 and 8 are going to be a little bit of an extension. You do not have to do this, but it's a good challenge. Sometimes our probability of events, our and events, might overlap. Even our or events, if you think about it. So if you have the probability of overlapping events, you may have to subtract out the overlap. Let's look at this one. From the given list of Steeler players, if we chose one randomly, what is the probability that the one we choose will have the number 2 or the number 9 as part of their playing number? Well, let's count them. How many have a number 2? We have 1, 2, 3. That's all of them. So we have 3 out of the 14 players listed here. Or means to add. All right, well, how many have a 9 in their number? 1, 2, 3, 4, 5. So 5 out of 14. Now here's the deal, and maybe you noticed as I was counting, sometimes the events can overlap, right? If you throw a die, you can't roll a 1 and a 3 at the same time, not on one toss. Those do not overlap. But in this event, we do have one player who has the number 2 and the number 9 in their number, right? That's Monday. So when there is overlap, sometimes you have to subtract out the probability of both, of 2 and 9. So if you think about it, here, there's 3 out of the 14 players that have a 2. Add that to 5 out of the 14 players that have a 9. And you would actually have to subtract out the one that you counted twice. Who did we count twice? Monday. There's one player out of the 14 that has both a 2 and a 9. So let's subtract this out. This will be your probability. So you will be covering only mutually exclusive events in this chapter. This is an inclusive event where there's overlap. The events are inclusive with each other. So this would be 8/14 minus 1, or 7/14, which is 1/2, which is 50%. So it actually came out as the same answer as number 5, different problem though. Let's look at one more situation that has an overlap. 2 number cubes are tossed. What is the probability of rolling a prime and a multiple of 3 on both tosses? So I want to know the probability of a prime and a multiple of 3. So let's think about it. For the primes, what numbers would be prime? 1 is not prime. That's often what I hear, but it is not prime. It is just kind of off on its own. 2 is prime, 3 is prime, and 5 is prime. Those are only divisible by 1 and themselves. Then what are the numbers that are multiples of 3? Just 3 and 6. I think it's helpful for a problem like this to show a chart and show the different cases. So this one right here is going to be die 1. So this is dies or die 1. And this down here would be dies or die number 2. Okay? So let's see, let's kind of mark. If you get a prime on the first die, you can get a 2 on the first die with a 3 on the second die. That'll be a prime and a multiple. You can also get a 2 and a 6, right? Then on die 1, you can get a prime of 3 on the first one and multiple of 3 on the second one. 3 on the first one, multiple of 3 on the second one with 6. The only other prime left for die 1 is 5. You could get 5 with 3 or 5 with 6. That would satisfy this event. Now switch it around. So we first looked for the primes on here. Let's now look for the multiples of 3 on here. So if you get a 3 on here, just flipping it around, and then a 2, that would work. If you get a 3 and a 3, that's already marked, and a 3 and a 5, that would work. Then if you get a 6 on here, you can get 6 with 2, 6 with 3, and 6 with 5. So notice here that the events overlap, right? What is the probability of getting a prime? Well, those would be the green ones. So I can get, what's the probability of getting a prime and then a multiple of 3? 1, 2, 3, 4, 5, 6 ways out of how many different possible outcomes could you have? Well, 6 times 6 gives me 36 different outcomes. Or you could switch it around. You could get, we did the prime first, now let's do the multiple of 3 first. That would be the red. How many different ways did you get the multiple of 3 first and then the prime? 1, 2, 3, 4, 5, 6. But you can see from my chart that we do have an overlap. This event right here, this box right here was counted twice. I marked it twice. I need to subtract out the one that is both. If I get a 3 and a 3, I could read that either way, and I counted it twice as getting a prime and a multiple of 3. So my probability here would be 1136. If you wanted the percent, that is about 31%. Again, this is an extension, okay? The next page in your notes is also an extension. It deals with probability of compound events, which is what we just talked about. So you learned this. This is your extension. This is the challenge. When you have events that are inclusive, they overlap, you might have to subtract out the overlap. If you would like to try this, read over the example and try the sample problems 1, 2, and 3. I'm going to post the answers to 1, 2, and 3 right after this in the video, so you can always come back and fast forward and check your work, okay? You're done at this point, or if you want to pause, try these 3 problems. I'll show you the answers in a second. So if you did decide to do this extension worksheet, the answers to 1, 2, and 3 are right here for you. I put the letters E and I for exclusive or inclusive, and then the probabilities right next to them, and number 3 was D. If you have any questions, please let me know or check with your teacher. But again, the inclusive events are an extension for your classroom.